solving inequalities with the word and. I want to start out with an example. Notice I have two inequalities here. It says here in our example to find all values of x which satisfy the statements x is less than negative 3 and x is greater than or equal to negative 7. Now, whenever we see the word and when dealing with inequalities, and really means both. What we want to do is find all values of x which satisfy both of these statements at once. Why don't I just start out by graphing each of these statements. Let's graph x less than negative 3. Let's take a look at that one. If I draw a number line, I'll put my negative 3 here. I'm looking for all x's that are strictly less than negative 3, which means I have to go to the left. Okay? Now, let's graph x greater than or equal to negative 7. Maybe there is negative 7. There might be my negative 3. Now I want to graph all values of x which are greater than or equal to negative 7. Now again, when we see the word and, it means both. So we have to find an interval such that our interval satisfies both of these at the same time. Well, notice on this interval, negative infinity to negative 3, it does not include any of these points over here. So the points that are in common with both of these intervals is going to be from negative 7 to negative 3. Notice I cannot include any points over here because they are not included here. So the common points in both of these intervals at once are going to be just the points between negative 7 and negative 3. Now we have to make sure that we get the endpoints correct. Now remember, x could equal negative 7, so I can put a square bracket. And our x had to be strictly less than negative 3. And we draw a solid line in between to represent that all of those values are in our interval. Now the interval notation is pretty easy. We'll start from negative 7, including, and we'll go all the way up to negative 3 with an open parenthesis. All right, let's try another example. Okay. Let's find the solution to the given inequality, and we'll graph it, and we'll find the interval notation. So let's graph it first. I'm going to graph each of these individually, and then we'll try to figure out what are the common points. So x less than or equal to 2. I'll put a 0 there for reference. Maybe the 2 is here. So I need to graph all points that are less than 2 or equal to 2. So that means a closed bracket. And we'll draw our solid line to the left. Okay. Now we'll go ahead and draw the next graph. I need to draw all values of x that are greater than or equal to 4. So x could equal 4 or bigger. So that means I'll have a solid bracket going to the right. Now remember, the word and means what's in common with both. Now take a look. Do we have any common points in each interval? Well, it doesn't look like it. So what are we going to write? There's nothing in common with this interval and this interval. What we say is, we say that the interval, or the intersecting, or the points in common are nothing, and in mathematics, we'll use this symbol, which means empty set. There is nothing in common. Now, if I wanted a graph, well, I would just simply put the number line with nothing on it. Okay? So the solution is nothing. There's nothing in common. We'll try one more example. I have a little typo here. Both variables have to be the same. So let's see. Find the solution to the following inequality and give the solution in graph form and interval notation. So notice, This isn't in the nice form of the other two examples. The other two examples we had something like z less than or equal to 2 or something like that. Well, all we have to do is solve each of these independently and then figure out what they have in common. So let's solve this inequality. Let's add 4 to both sides. And remember, when I add to either side of an inequality, it does not affect the direction of my inequality. So I get 3z still less than or equal to 12. Now divide by 3. Z less than or equal to 4. We'll solve this one. 4z minus 1 less than or equal to 15. Again, we want to isolate the z, so I'll add 1 to both sides. My 1's cancel. Again, the direction of the inequality is not affected since I'm adding. And now to solve for the z, I'll divide by 4. Again, when we multiply or divide by a positive value, that does not change the inequality as well. So notice, both of these intervals are exactly the same. So really, I just need to write one interval representing both. I don't need to do two separate since they're the same. So let's see, my z's must be less than or equal to 4, which means a solid or a closed bracket on the 4 going into the left direction. The problem asks us to give the graph and the interval. Well, the interval, of course, the left side is negative infinity. Again, always open on the infinities. So negative infinity all the way up to 4, and we can include the 4. So a little work to do these and inequalities, but with some practice, you should get them down with no problem.